All right, class, welcome back to Chapter 6. Now we are in Lesson 2 on page 449. Today we begin our discussion on the equations of linear relationships. So let's go ahead and start with our real-world example. It says here, we have this young lady named Antonella. Her family is going on a trip to visit a museum. Each person must pay an admission fee of $12. In addition, the museum charges a one-time fee of $15 to cover the tour guide. Let's investigate the relationship of total cost to number of people. So there's quite a bit of information we're going to talk about. First of all, we know that when going to this museum, each person must pay $12. So $12 per person. And actually, I'll make a little note over here. It's $12 per person. So there's our unit rate. Plus, because it even says in addition, which means we're going to be adding on top of that, the museum charges a one-time fee of $15. So we're paying $12 for every person plus $15 just for the tour guide. Now, I'm going to go ahead and rewrite this in a moment, but let's go ahead and just go on to the first question that's being asked now. In step 1, we are asked to complete the table to determine the total cost of admission. So, if 0 people go, what's the cost? Well, normally you might think if nobody goes, there's no cost, but it does cost something to the museum. If we charge $12 per person and 0 people go, as we have right here in our chart, that would be $12 times 0. Well, that's $0. But we still are charged $15, or the museum spends $15, just to have the tour guide ready and available in case someone does show up. Now let's take the more likely scenario that we have where people actually come to this museum. So let's keep continuing with the chart. Now, if one person shows up, that's $12 times that one person, which is just $12, plus 15 gives us a total of $27. Repeat the process again. 2 people times $12 is 24, plus 15 is going to give us a total of, that's right, 39. Hopefully you beat me to it before I said it. And we'll continue on the rest of the chart. If 3 people go, that's 3 people times 12, which is 36, plus $15, which is going to be 51. I hope I didn't misspeak earlier. I think I said plus $12, and actually it's plus 15. Anyways, these numbers are still right. Now, $4 a person, or excuse me, 4 people times $12, that's 48, plus 15, that's going to be 63. If 5 people go, that's 5 people times the $12 a ticket it is for each one. And 5 times 12 is 60, plus 15 gives us 75. And we could conceivably keep going on infinitely for any number of people. But we don't need too many for this example. Now, we did the first part. We completed the table. Next, graph the data in the table on the coordinate plane. So if we scroll down a little more, they give us a nice little table down here. And we'll go ahead and start to plot or graph our data. So we know that if nobody comes, they are charging about $15 per person. Now, I can't really read this graph too well, so I'm going to try to find some numbers that work a little easier for me. And let's see what I have here. 75, 63, 51, 39. All right, so let's go ahead and just go for it. So 0, we're going to get about, here's 12. We'll say 15 is just a little bit above it, like right there. For one person, that's $27. So one person, 24 is right here. So 27 is just a little bit above that. Number 2, when we have 2 people, that's $39. So 2, here's 36. We'll go a little bit above that. For 3 people, that's $51. That's going to be a little bit above the 48 line, something like that. For 4 people, that's going to be $63. That's just above the 60. And then for 5 people, we have $73, which is just right above the 72 line. Now, to me, this looks like it might be a straight line, mostly, until you saw that last part there. That goes on forever. But I can't tell for sure. So we're going to have to follow on some other process to help us realize if this really is a linear or straight line relationship. So we did part 2. Let's look at part 3. Does this situation represent a linear relationship? Explain. Well, I'm going to take yesterday's lesson and go ahead and analyze the graph itself. Here on the graph, I know that it is changing at a constant rate of plus 1, because everything is being added by 1 to give you the next box. Over here, let's check if I have a difference. So from 15 to 27, 15 to 25 is 10 plus 2 more. That's an increase of 12. 27 plus 10 more, 37 plus 2 more, have the same increase here. So I notice I have the same rate of increase on both the y for the cost and the x for the number of people. Because this is constant and because this is constant, then I know for sure that I do have a linear relationship. So I would say yes. Oops, my pen's not working like always. Yes, it is linear. And I have to explain. This is the most important part. Because I have constant rate of changes in both the x and the y columns. Because I have, I'll put the abbreviation CROC, constant rate of change. Now, let's go ahead and look at number 4. Is this situation a proportional linear relationship? Explain. Well, it definitely, I would say, is linear. We just proved that. But is it proportional? And the answer, if you're paying attention to the last chapter, is no. And hopefully you can explain why. Whoops, I didn't mean to do all that there. Let me erase that. I guess I can't. It's not it's not proportional because, and I know you're not supposed to begin a sentence with because, so you guys can reword it, because it does not go through, and I'm talking about the graph here only. How do I know that this graph is not proportional? Because it does not go through 0, 0, the origin. So that's how I know this relationship is not proportional. If it's proportional, it must go here through the origin. Anywhere else up here or over here, it is not proportional. And that's just based on what we learned at the end of chapter 2. Now let's move on to number 5. The equation that represents this situation is y equals 12x plus 15. Before I even move on, let me explain where this comes from. The y is how much money the museum is making. So the amount of money the museum makes is equal to $12 for each person plus the $15 just to have the museum guide there. That's what this formula is telling me. So it says now, explain why the number 12 is multiplied by x. The reason why it's multiplied is because we charge $12 per person. Because the museum, charges $12 per person. This is a unit rate the way I wrote it. $12 per one person. That's what's happening. So every person you have that comes into this museum, it'll be multiplied times 12. On the bottom over here, we had people or visitors. And over here, we just had dollars. I forgot to fill in that graph when I first did it. And that hopefully didn't throw you off too much. Now let's go ahead and jump right into our next examples on the next page on 450. All right, so now we're back here on page 450. Our topic for this page is graph linear equations using tables. And we have some information. Below it says, an equation such as y equals 60x is called a linear equation. A linear equation is an equation whose graph is a line. So right there, big definition. A linear equation is an equation that if you graph it, the graph will give us a straight line. You can graph a linear equation by making a table of ordered pairs. This is probably one of the biggest ideas for Algebra 1. So I'm going to show you, beginning with example 1, how you're going to approach all your work from here on out. And this is true for algebra, every class, every school ever that teaches this topic in the beginning. So let's go ahead and jump right into example 1. So they ask us to graph y equals 2x plus 1. I'm going to go ahead and clear most of the screen off because I'm going to show you how to set up this whole thing nice and neat. So let me cross this out. Actually, I'll go to about right here because I want to use this graph over here to explain in a little while. So here's what you're going to do. We have our table for the most part. Whoops. Let me go and get this going. Okay, so let's go ahead and adjust this really quick. There we go. So now, I have this equation, y equals 2x plus 1. You're going to make a chart. Here you're going to have x's. Here you're going to have y's. So here in this space here is whatever the equation is they give you. So here, to get y, I'm going to multiply 2 times x plus 1. All right? Now I'm going to go ahead and change the side of my pen just a little bit. That should work. And let's go ahead and pick some numbers. Now looking at this table, whenever you're asked to graph an equation, it's always good to pick some positive numbers, some negative numbers, and 0. The easiest ones to actually use are going to be negative 3, negative 2, negative 1, 0, 1, 2, and 3. The smaller, the better. It's like 100% of the times easier. So now let's go ahead and let's do what it says. These numbers I picked for x are just random numbers. You can pick any number you want, but I suggest always picking negatives, positives, and of course 0. These numbers are the easiest to do math with. And I know I haven't filled out some other parts of the table yet, but that's okay. So here's how we're going to work the table. Whatever x is, I'm going to multiply it times 2 and add 1. So for the first part, I'm going to multiply 2 times negative 3 and then add 1. And then I would multiply 2 times negative 2, then add 1. Then I'm going to take 2 times negative 1, add 1, 2 times 0, and then add 1, 2 times 1, times a positive 1, excuse me, and then add 1, 2 times 2, and then add 1. You really don't need to have the positive sign right here. That was just a mistake I made. And then you have 2 times 3 plus 1. So now you follow PEMDAS. 2 times negative 3 is a negative 6. Plus 1 step in the positive direction, that's a negative 5. 2 times negative 2 is a negative 4. Plus 1 step in the positive direction, that's a negative 3. 2 times negative 2 times negative 1 is negative 2. Plus 1 step in the positive direction, that's a negative 1. 2 times 0 is 0. Plus 1 is 1. 2 times 1 is 2. Plus 1 more is 3. 2 times 2 is 4. Plus 1 is 5. 2 times 3 is 6, plus 1 is 7. So now I have some x's I plugged in, some numbers I plugged in, and then I have the y's, the numbers I got out. What I'm going to do now is make some points. Whatever I plugged in compared to whatever I got out. So when I plugged in a negative 3, I got a negative 5, as we see here and here. When I plugged in a negative 2, I then got a negative 3 for an answer. When I plugged in a negative 1, I got a negative 1 for an answer. When I plugged in a 0, I get a positive 1 for an answer. When I plugged in a positive 1, I got 3 for an answer. When I plugged in 2, I got 5 for an answer. And when I plugged in 3, I got 7 for an answer. So all these first numbers are the things I plugged in, my input, my x values. All the answers I got out after doing PEMDAS and following the equation are my y values or my outputs. Together they make points. So for example, if I go back to negative 3, negative 5, that means back 3, down 5, and leaves a point right here. Next point, negative 2, negative 3. Starting from the origin, I go back 2, down 3. And look, another point on my graph. When I go negative 1, that means back 1, down 1, and that's a point right there. Then when I go to 0, 1, 0 means I don't go left or right, but instead I just go up 1 point. Here, I go 1, comma 3. That's positive 1, up 3. That's this point right here. Then I have 2, 5. Positive 2, up 5. That's this point. Unfortunately, my 3, 7 point won't fit, but it would be about right there. If the line kept going, that's where it would be. So what happens is, if your equation is a linear equation, as this one is, then you will get a series of points that should all lie on the same straight line if you graph them out. If you have a point that's not on the line, a couple of things might have happened. You might have misplaced the dot. You may not have read your graph correctly, or more than likely, some of your work over here in this part was not done correctly when you did PEMDAS. If it still doesn't work out, then it may just be that the graph you have is not, in fact, linear. Now, having said that, let's go ahead and look at the rest of this example, if there's anything else. And here, this table does the same exact thing that I did. It just did it for you already, but I explained it to you how to work it out. So, yes, we do know that we have a linear equation. What you're going to do now is look at the Goddets and try A and B. I would suggest, actually I'm going to tell you guys to go ahead and do these equations in a table just like the one I did above, and then fill in your data after down here. Don't try doing the work in all the spaces. work it out separately, and then fill in all these spaces. And then also attempt to graph. After you've done A and B, go ahead and raise your hand or ask your teacher for some help or clarification, or just to make sure to verify that you did it right. Good luck, and I'll see you on the next page. All right, here we are on page 451. On this page, we're going to specifically work on graphing real-world data. And it says underneath, real-world data can be modeled by a linear equation if there is a constant rate of change. So there's a big idea. You can model real-world data with a linear equation if there is a constant rate of change. Whenever you see this abbreviation from now on, that stands for constant rate of change, CROC. Now, this is the most important part, and we'll see how it's applied in this second example down below. So, whoops, I didn't mean to do that. Let me go ahead and back up some, because now I went too far, I'm sure. All right, I'm not sure what happened there. 1 second. I apologize for that. I lost my spacer, but now I'm back. So, to recap for this beginning of the section so far, we can model linear equations if there is a constant rate of change, C-R-O-C, CROC. So now let's go ahead and look at our second example here. A outdoor adventure company charges $9 per hour. That's a unit rate, which means this is going to be multiplied by something, for a mountain bike plus a $5 fee for the helmet. So we have two things, $9 for every hour plus $5 for the helmet. The equation C equals 9H plus 5 describes the total cost, C, for H hours to rent a bike. Represent this linear equation with a graph. So this equation, how much we pay, which is the letter C, is equal to $9 for every hour, or 9 times H, for every hour that we rent the bike, plus a $5 flat fee just for the helmet. So they don't charge us every hour for the helmet, just for the bike. The helmet is just one price you pay one time. So what they did here is it says select any 4 values for H. Select only positive numbers because H represents time. Make a table. The reason why we don't have 0 or negative is because you can't do 0 hours or negative. You can't have negative time. Either you have hours or you don't. And the hours you do have all have to be positive. So here's what they did. They said, okay, 1 hour, 9 times 1, which is $9, plus the $5 helmet fee, that's 14. 9 times 2, for 2 hours, that's $18, plus the $5 helmet fee, that's $23 total. 9 times 3 hours, that's $27, plus the $5 helmet fee, that's $32. 9 times 4 would be $36 for 4 hours, plus the $5 helmet fee, which is $41. And then they put these two together. Each one of these came together to make the points that we have right here. 114, 223, 332, and 441. So that's how you make a table, and we saw how to do this in the last example. So we'll go on to the next part. Step 2, graph the ordered pairs and draw a line connecting the points. The question was asked earlier, well, does it really matter if the line is that straight? Well, the whole purpose of the lesson is to be able to explain and describe a linear relationship, which is basically the graph of a straight line, then yes, your graph should be straight. I suggest instead of carrying a ruler around that maybe you guys just use your IDs. So let's go ahead and graph these points. When we rent a bike for 1 hour, it costs us $14. That's this point right here. When we rent a bike for 2 hours, the total cost for everything is $23. When we rent a bike for 3 hours, the total cost is $32. And when we rent a bike for 4 hours, the total cost is $41. But let's say that you don't have a graph that's like this already made nice, or a graph at all. Then we should look for the CROCs, the constant rates of change. Because we should have one in the X category, and we should have one in the Y category, or in this case, the H. Over here, do we have a constant rate of change? And if you're paying attention, you will see that we do. Everything is increasing by 1. So in the X column, everything's increasing by 1. That's our constant rate of change. In the cost, or you can even call it the Y column, it doesn't really matter, we have these numbers. 14 to 23, that's plus 9. 23 to 32, that's also plus 9. And 32 to 41, that's also plus 9. So in the total cost column, we have a constant rate of change of positive 9. Because we have constant rates of change both here and over here, then yes, in fact, we know we have a linear relationship. For sure. you didn't even have to bother graphing yet. But luckily for us, they had one done already. So now let's take what you've learned and see how well you're paying attention. Do got it letter C about Malik's family. Here they give you the equation. Pick some numbers that make sense to the story. Remember, the smaller you pick, the easier the math will be. And then now you have to create your graph. Remember, when you create graphs, you don't always have to start by 1. You can count by 1s, 2s, 3s, 4s, 5s, halves, 3/4, whatever you want. Whatever you need to do to make the graph fit. But I am going to tell you for this, got it, do not just rely on the graph to answer your question. Figure out, do you have a constant rate of change over here in the x column and over here in the y column? If so, describe it and then answer your question about it being linear or not. All right, I know they want you to do the graph and you will make it, but to get a definitive answer, a for sure answer, look at the constant rate of changes here and here. Good luck, and raise your hand or come before or after school if you have any questions about this example. If not, I'll see you on the next page for the final part of this lesson. Here we go, finally, example 3. We have a veterinarian charged a customer $80 for an office visit. The vet charges $35 for office visits plus $15 for vaccinations. The equation 80 equals 15x plus 35 describes the total charge for x vaccinations. Use the equation and graph to determine how many vaccinations the customer's pet received. So let me re-explain this to you guys. We know that a vet, some pet doctor somewhere, charged somebody a total of $80. That's what we see right here. That's his total. That's how much he ended up coming out of his pocket. What we do know about this particular vet is that it's $35 just for showing up, even if he doesn't do anything. If you see the vet, just like a doctor, they're going to charge you something. And then where the charges add up is right here. $15 for every set of shots you got to give your dog, cat, or whatever your pet is. So the question they want to ask us now is, if we spend $80 and we know how much the doctor charged just for showing up, then how many of these vaccinations did our pet get? And here's where you would want to do some backwards equation solving, or you could actually just graph it. And here in this case, they already gave us the graph. So we have to say, okay, when does it equal $80? Right here. $80 is what we were charged. Well, then how many vaccinations is that equal to? So I'll come straight down, and bam, just from reading the graph, I could see here that there was 3 vaccinations given. And that's the easy way to do it with a graph. But let's say you didn't have a graph. Then you would have to use our old friend for solving 2-step equations. Do you guys remember making the t-chart? This is coming back to haunt you now. X is being multiplied times 15 and then added by 35. What's the inverse of those things? We're going to divide by 15 and subtract 35. The one we do first depends on backwards PEMDAS or SADMEP. So the first thing I would do is subtract 35 from both sides. 80 minus 35 is 45. Equal sign drops down. The 15x drops down. 35 minus 35 is 0. Now, I have to divide by 15. I'll divide this by 15 and this by 15. 15 divided by 15 is 1x, and 45 divided by 15 is 3. Therefore, since x talks about the number of vaccinations my pet got, then I know my pet got 3 vaccinations. And that's just shown to me right here. Bam. And again, right here. And again, right here. So now I have the words. I have the graph. I have the math. You have all 3 things telling me the same answer. And that's what you want with algebra. That's the beauty of algebra. There's more than one way to prove your answer is right. If only one answer says you're right and the other 2 things say you're wrong, then you're totally wrong somewhere. Now, on your own, you guys need to go ahead and practice guided practice number 1, number 2, and we'll just work on those 2 for now. You'll receive the rest of your homework assignment in class. Good luck, and as always, make sure to see us before or after school, or ask us during class if time permits about any questions you may have. Good luck, guys, and thank you.